Welcome to the deep dive. Today, we're going to tackle Packer,
Yeah.
a tool that's making waves in the world of machine images.
Right.
And judging from this stack of articles, documentation, even some training materials you've sent our way,
Yeah,
it seems like you're ready to go from Packer what to Packer, I got this.
that's right. And it's a journey worth taking, especially with how much you're already working with cloud platforms and infrastructure as code.
Okay.
Packer really fits in perfectly with those trends.
Okay, so let's start with a little trip down memory lane.
Right.
Remember those golden image server carts being wheeled around data centers?
Oh, yeah.
That was building servers the old-fashioned way.
The pre-cloud era, indeed.
Yeah.
Back then,
Yes.
each image was like a time capsule, quickly becoming outdated and
Yeah.
difficult to manage.
Yeah.
It wasn't exactly a recipe for consistency, let alone security.
And from what I'm seeing in these sources, even when virtualization and cloud platforms came along,
Yeah.
those old problems of image sprawl and configuration drift didn't disappear, did they?
You're absolutely right. Configuration management tools like Puppet and Chef
Right.
helped automate things to some extent,
Yeah.
but the base images themselves remained a challenge.
Okay.
Even Vagrant, which is great for local development,
Right.
relied on these boxes that had similar issues.
So it sounds like we were still stuck with a lot of manual work,
Yeah,
inconsistency, and potential security risks.
for sure.
Not exactly a recipe for smooth and reliable deployments.
Exactly, and that's where Packer comes in.
Okay.
Packer, created by HashiCorp, is a free and open source tool that solves the problem of building identical machine images
Okay.
for multiple platforms.
Right.
We're talking AWS, Azure, GCP, VMware, Docker, all from a single configuration.
Hold on. So instead of juggling different tools and processes for each platform,
Yeah.
I can use Packer to build consistent images for everything. That's a pretty big deal.
It really is. And it's not just about consistency.
Okay.
Think about the times you've struggled to get a testing environment that perfectly mirrors production,
Oh, yeah.
or the security risks when every server is a unique snowflake.
Right.
Packer tackles those problems head on by automating the build process and creating truly immutable infrastructure.
Okay. I'm starting to see the bigger picture here.
Good.
But before we dive into how Packer actually works,
Yeah.
can you give me an example of a real-world problem it solves? Something that really highlights the value it brings?
Absolutely. Imagine you're deploying a web application.
Okay.
You have developers working on their local machines,
Right.
a staging environment for testing,
Got it.
and then the production environment where your users access the app.
Right.
Traditionally, setting up and maintaining these environments could be a nightmare,
Yeah, I can imagine.
with each one potentially having subtle differences that lead to unexpected issues.
For sure.
Packer changes all of that.
So by using Packer, I can ensure that the base images used in each environment are identical,
Yes.
minimizing the chances of those "it works on my machine" headache.
Exactly. Packer acts as a central source of truth for your machine images, ensuring consistency and eliminating configuration drift between development, testing, and production.
Got it.
It's a game changer for teams practicing continuous delivery and striving for that elusive dev-prod parity.
Okay, that example really brings it home.
Yeah.
But I'm still curious about how Packer pulls this off. I'm
Yeah.
seeing terms like templates, builders, and provisioners in these sources.
Right.
It seems like there's a lot going on under the hood.
There is, but it's actually quite elegant once you grasp the key concepts.
Right.
Think of a Packer template as your blueprint.
Okay.
It defines everything about your desired machine image,
All right.
from the base operating system to the software you want installed,
Got it.
using a language called HCL.
HCL, is that related to Terraform?
You got it.
Okay.
HCL, or HashiCorp configuration language,
Right.
is designed to be human-readable and easy to work with,
Okay.
and it's used by both Packer and Terraform.
So that means if you're familiar with Terraform, you'll feel right at home with Packer's configuration language.
that.
That's a nice bonus. So the template is like the recipe
Yeah.
written in HCL that tells Packer how to build the image.
Right.
What about actually creating the image on different platforms like AWS or Azure?
That's where builders come in.
Okay.
They're essentially plugins that interact with specific platforms to create the actual machine images.
So you'd have a different builder for AWS,
Right.
Azure,
Yeah.
VMware, and so on.
Exactly.
Each builder knows how to communicate with its respective platform and create images in the correct format.
That's right.
So the builder acts like a specialist speaking the language of the specific platform we're targeting.
Exactly.
What about configuring the software on the image? Installing packages,
Yes.
setting up users, and all that?
That's the job of provisioners.
Okay.
They are tools that run within the machine while it's being built,
Okay.
installing software, configuring settings, and basically preparing everything before the image is finalized.
So the template lays the foundation. Yeah. The builder constructs the house.
Right.
And the provisioner does the interior design,
Perfect analogy.
making sure everything is set up just the way we want it.
Exactly. And the beauty of Packer is that it supports a wide range of provisioners,
Okay.
from simple shell scripts to sophisticated configuration management tools like Ansible and Chef.
So if I'm already using Ansible to manage my infrastructure,
Uh-huh.
I can use it to configure my Packer images as well.
That's right.
That's fantastic.
It is, and it highlights one of the key advantages of Packer. It's flexibility.
Okay.
You can leverage your existing tools and workflows, integrating them seamlessly into your image building process.
This is really making those old server cart days seem like ancient history.
It's a different world altogether.
Yeah.
But before we get too carried away celebrating the present,
Okay.
I think it's worth pausing to understand how we got here.
All right.
Why did the need for a tool like Packer arise in the first place? What problems were people trying to solve?
You're right. Understanding the history can give us a deeper appreciation for the solution.
Exactly.
So let's take a step back and look at how the challenges of image management evolved.
Well, as organizations started embracing virtualization and cloud platform,
Right.
the number of images they needed to manage exploded.
Yeah.
Think about it.
Yeah.
Different operating systems,
Right.
varying software configuration,
Wow.
multiple cloud providers.
Okay.
It quickly became a logistical nightmare.
So that image sprawl problem we talked about earlier.
That's exact.
Trying to keep all those images up to date and consistent manually sounds like a recipe for disaster.
Exactly. Inconsistent images lead to all sorts of headaches,
Right.
unexpected behavior in different environments,
Yeah.
difficulty troubleshooting,
Sure.
and potential security vulnerabilities.
Okay.
It was a major drain on time and resources.
So automating the image creation process became essential.
Yes.
Not just for efficiency, but for reliability and security as well.
Precisely. And that's where Packer steps in. By using a single template to define your images,
Right.
you ensure consistency across all your platforms.
Sure.
And because the build process is automated,
Audit.
you eliminate the risk of human error and ensure that those security best practices are applied consistently.
This is all starting to make a lot of sense. But
Oh.
before we dive deeper into Packer,
Yeah.
I'm curious, were there any other tools people were using before Packer came along?
Uh-huh.
What did the image building landscape look like?
There were definitely other tools.
Okay.
VWE, for example, was a popular choice for building Vagrant boxes,
Okay.
but it lacked the multi-platform support that Packer offers.
So Packer's ability to build images for a wide range of platforms,
Yes.
from public clouds to virtualization environments,
Right.
gives it a significant advantage. What about other tools?
You had tools like Image Factory, which was a Red Hat imaging tool,
Okay.
and Box Grinder, which supported a variety of platforms and cloud environments.
Right.
Each tool had its strengths and weaknesses,
Ah.
but Packer stood out with its combination of flexibility,
Right.
ease of use, and a vibrant open source community.
A vibrant open source community is always a good sign. Means there's a lot of support available.
Right.
And you can often find pre-built templates and configurations that you can adapt to your needs.
Absolutely. And Packer's integration with other HashiCorp tools like Terraform is another major plus.
Okay.
It fits right into that infrastructure as code ecosystem.
Okay, so we've established that Packer is solving a real problem.
Yes.
Offers significant advantages over alternative tools.
Right.
And integrates well with other popular technologies.
Mm-hmm.
But I'm ready to see it in action.
Yeah.
What are some specific situations where Packer really shines?
Great question. Let's explore some of the common use cases where Packer can really make a difference.
Sounds good to me. Let's dive into those use cases when we come back in just a moment.
Sounds good.
All right, so we've set the stage and explored the reasons behind Packer's rise in popularity. But let's get down to the nitty-gritty. How does this thing actually work? What's going on behind the scenes when Packer builds these machine images?
That's where we dive into the heart of Packer, those core components that make it tick.
Okay.
We've touched on them briefly, but let's unpack them fully. Templates,
Okay.
builders,
Right.
provisioners, and a few other essential pieces.
Okay, let's start with templates.
Okay.
I'm picturing them as the blueprints that guide the entire build process, right?
Exactly. A Packer template is essentially your instruction manual,
Okay.
meticulously outlining the configuration of your desired machine image.
All right.
You have the choice of writing them in JSON or HCL.
HCL again. That shared language with Terraform seems like a real advantage for anyone already working in that world.
Absolutely.
Yeah.
And it's not just about familiarity.
Right.
HCL offers features like modules and variables that make your templates more flexible and reusable.
Okay.
You can define variables for things like the cloud region you're building in,
Right.
instance sizes, or specific software versions.
So instead of creating separate templates for every little variation,
Yeah,
I can use variables to make them more adaptable and reusable. Smart.
precisely. It's all about working smarter, not harder.
Right.
And within a template,
Yeah, okay.
you have several key sections or blocks that define different aspects of the build. One of the first you'll encounter is the source block.
Source. That makes sense. Packer needs a starting point,
Right.
an existing image that it can use as a foundation.
Right. Exactly. Think of it as the raw ingredients before the real cooking begins.
Okay.
You can point Packer to an image from a public cloud marketplace,
Right.
a private repository, or even a local file on your system.
Okay.
The source block is where you specify all the necessary details, like the image ID and region.
And what's really cool is that you can define multiple sources within a single template, right?
You got it.
So I could have one template that builds images based on Ubuntu,
Yeah.
CentOS, or whatever other operating systems I need.
That flexibility is baked right into Packer's design.
Okay.
But the real magic happens in the build block.
Right.
This is where we roll up our sleeves and start assembling the image.
Okay, if the template is the recipe and the source is the raw ingredients,
Yeah.
then the build block is where the actual cooking happens.
Right.
And that's where those builders come in.
Exactly. Remember how we talked about Packer's ability to create images for multiple platforms?
Right.
Well, each builder is like a specialist,
Okay.
an expert in a specific platform.
Got it.
You'll have builders for AWS,
Right.
Azure, GCP, VMware, Docker,
Okay.
each one tailored to the nuances of its environment.
With so many platforms and subtle differences between them,
Yeah.
how does Packer make sure it doesn't mess up the instructions for each one? That seems like a huge challenge.
That's where the brilliance of the builder plugin system comes in.
Okay.
Each builder is designed to handle the specifics of its platform, taking care of the underlying details and complexities so you don't have to.
Okay.
You simply define the desired configuration within the build block,
Right.
and the builder translates those instructions into the language of its platform.
So I can define things like instance types,
Yes.
networking configurations, security groups,
Right.
all within the build block.
Correct.
And the builder will make sure it's all implemented correctly on the target platform.
Precisely.
Huh.
It's like having a team of image building experts at your fingertips.
Wow.
Each one fluent in the language of its respective platform.
Okay, so we've got the template setting the overall direction,
Yes.
the source providing the base ingredients,
Right.
and the builder constructing the image on the chosen platform. What about actually configuring the software on that image, installing packages,
Yeah.
setting up users, tweaking configurations, all that good stuff?
That's where provisioners step into the spotlight.
Okay.
They're the tools that execute within the machine while it's being built, installing software, configuring settings, and essentially transforming that raw image into a functional and ready-to-use system.
So if the builder constructs the house,
Yes.
the provisioners are like the interior designers,
If we
making
could-
sure everything is set up just the way we want it.
Right.
And thinking back to your notes on securing cloud deployments,
Yeah.
this seems like the perfect place to implement some security best practices. Right?
Absolutely. And that's one of the areas where Packer really shines.
Okay.
You can use provisioners to integrate security scanning tools right into your build process.
Right.
For instance, a provisioner can run a vulnerability scan as the image is being built,
Okay.
catching potential security issues early on.
That's a game changer.
It is.
It's like having a security expert inspecting every nook and cranny as the house is being built,
Right.
making sure there are no vulnerabilities or weaknesses. What other types of provisioners are commonly used?
Well, you have a wide range of options.
Okay.
One of the simplest is the file provisioner,
Oh.
which lets you upload files from your local system to the machine being built.
So if I need to add configuration files,
Right.
scripts, or other data to the image,
Yep.
I'd use the file provisioner, simple and straightforward.
Exactly. And then there's the shell provisioner,
Okay.
which allows you to execute shell scripts on the machine.
So the shell provisioner gives me a lot of flexibility
Yes.
to run custom scripts and commands during the build process.
Exactly.
What about if I'm already using a configuration management tool like Ansible or Chef?
Packer has got you covered.
Hmm.
There are dedicated provisioners for Ansible Chef,
Right.
Puppet,
Okay.
salt stack, you name it.
Wow.
This means you can leverage your existing configuration management code and apply it seamlessly to your image builds.
Now that's what I call efficiency. I can use my existing Ansible playbooks to configure my Packer images, ensuring consistency across my entire infrastructure.
That's the beauty of Packer.
Okay.
It's not about reinventing the wheel.
Yeah.
It's about integrating seamlessly with your existing tools and workflows.
This is really starting to click for me.
Good.
So we've got the template providing the overall structure,
Yes.
the source image as our starting point,
Right.
the builder constructing the image on the chosen platform, and then the provisioners working their magic to configure the software and settings.
You've got it.
Yeah.
But there's one more piece of the puzzle. Post-processors.
Right, post-processors. These are the tasks that happen after the image is built, right?
Precisely.
Like cleaning up packaging and getting the image ready for deployment.
Precisely. Post-processors take the output of a builder
Okay.
or even another post-processor
Right.
and perform additional actions on that finished image.
Okay, give me some examples. What sorts of things do post-processors typically handle?
Well, one common task is compression.
Okay.
If you're building a large image,
Right.
you might want to compress it to reduce its storage footprint and make it faster to transfer.
Smaller images are always easier to work with.
Yeah.
So the post-processor can handle compressing the image into a more compact format. What else?
Another frequent task is uploading the image to a repository,
Okay.
whether it's a public cloud image repository,
Right.
a private artifact store,
Right.
or just a shared folder on your network.
So the post-processor can take care of getting that finished image to its final destination, ready to be deployed.
Exactly. And some post-processors can even convert the image into a different format.
Okay.
For example, you could convert a VMware image into a Vagrant box,
Oh, wow.
making it readily available for local development.
Interesting. So I could build an image using a VMware builder
Yeah,
and then use a post-processor to package it up as a Vagrant box for my development team.
exactly.
That's incredibly versatile.
It really is.
Mm.
And the beauty of it is that you can chain multiple post-processors together,
Okay.
creating a multi-step workflow that handles all the necessary tasks after the image is built.
Okay, this is really starting to paint a clear picture.
Right. Good.
So we have the template as our master plan,
Yes.
defining the variables,
Right.
the source image,
Wow.
the build process using builders and provisioners,
Yeah.
and then any post-processing steps to finalize and deliver the image.
That's right.
It's a powerful and elegant system.
It really is.
Yeah, indeed.
But there's one crucial component we haven't mentioned yet. Communicators.
Communicators. I vaguely remember that term from earlier.
Right.
What role do they play in all of this?
Communicators might seem like a minor detail,
Okay.
but they're essential to how Packer interacts with the machine during the build process.
Right.
They're the ones responsible for uploading files,
Okay.
running scripts,
Right.
and basically relaying all the instructions from Packer to the machine being built.
So they're like the messengers,
Exactly.
ensuring that all the commands and configurations are executed properly.
Precisely. And the type of communicator used depends on the operating system of the machine.
Okay.
For Linux,
Uh-huh.
it's typically SSH, allowing Packer to connect securely and execute commands remotely.
Okay, so Packer connects to the Linux machine via SSH to do its work. What about Windows?
For Windows,
Yeah.
Packer typically uses WinRM,
Okay.
which is Microsoft's remote management protocol.
All right.
It provides a secure channel for Packer to communicate with the Windows machine
Got it.
and execute all the necessary tasks.
So depending on the platform we're building for,
Yeah.
Packer will choose the appropriate communicator to get the job done.
Exactly.
It sounds like it all happens seamlessly behind the scenes,
Yes.
which is great for simplicity.
Exactly. Unless you have some very specific networking or security requirements,
Right?
you generally don't need to worry about the details of communicators.
Okay.
Packer handles that complexity for you.
All right, so we've now covered all the essential pieces.
Yeah.
Templates,
Yeah.
variables,
Right.
sources, builders, provisioners, post-processors, and even those behind-the-scenes communicators. We've really gone deep on the inner workings of Packer.
We have. But I think it's time to zoom out a bit and see how Packer fits into the bigger picture of infrastructure management.
Okay.
How does it connect with other tools and processes,
Right.
especially those related to infrastructure as code and automation?
That's a great point. We've explored the nuts and bolts.
Yeah.
But now I'm curious to see how Packer integrates with other tools and workflows,
Yeah.
particularly those you've been researching on automating cloud deployments.
Excellent. Let's move on to exploring those integrations when we return for the final part of our deep dive.
All right, we've taken a deep dive into the core components of Packer,
Right.
but I'm really interested in seeing how it all comes together in the real world.
Yeah.
How does Packer fit into those broader infrastructure as code workflows and automation trends you've been researching?
It's fascinating how Packer acts as a bridge between different tools and processes.
Okay.
Remember how we talked about a shared language with Terraform?
Uh-huh.
That's just the tip of the iceberg.
Right, HCL. But you mentioned that the integration goes beyond just a common language.
Exactly. Packer and Terraform are like two peas in a pod.
Okay.
They can work together seamlessly to automate the entire infrastructure lifecycle.
Right.
Imagine you have a Terraform configuration that defines your entire infrastructure,
Okay.
including virtual machines,
Right.
networks,
Uh-huh.
load balancers, the whole shebang.
So Terraform is orchestrating all the infrastructure components.
Precisely. And within that Terraform configuration,
Huh?
you can reference images built by Packer.
Oh, right.
So instead of manually specifying image details,
Right.
Terraform can simply pull in those pre-built consistent images
Okay.
that Packer has created.
So it's like a relay race.
Exactly.
Packer builds the perfect image,
Right.
and then Terraform takes it from there,
Right.
using it as the foundation for provisioning virtual machines and other resources.
You got it. It's a beautiful symphony of automation. And the beauty of it is that this integration extends to other tools in the HashiCorp ecosystem.
Okay.
You can incorporate configuration management tools like Ansible or Chef,
Right.
using them to define the software and settings within your Packer images.
So it's not just about Packer and Terraform.
Yeah.
It's about creating this interconnected web of automation.
Exactly.
Where each tool plays its part in creating and managing a robust and adaptable infrastructure.
Yeah.
No more manual handoffs or inconsistencies between different stages of the process.
Exactly. And this type of automation is becoming increasingly critical
Right.
as organizations move towards more dynamic and agile infrastructure models.
Got it?
Think about microservices,
Yeah.
containerization, and the rise of serverless computing.
Got it.
In these environments, you need to be able to spin up and tear down infrastructure
Yeah.
rapidly and reliably.
And that's where Packer really shines.
It does.
It allows you to create and manage those base images
Uh-huh.
in a way that supports this dynamic and automated world. Instead of treating servers as pets that you carefully nurture and maintain,
Right.
you can treat them as cattle, easily replaceable units that are created and destroyed as needed.
That's the essence of immutable infrastructure.
Okay,
And Packer is a key enabler of that approach.
got it.
By creating consistent and repeatable images,
Right.
you eliminate the risk of configuration drift and
Okay.
ensure that your infrastructure is always in a known and predictable state.
Right.
It's a game changer for reliability,
Uh,
scalability,
Right.
and security.
you know, thinking back to your research on securing cloud deployments,
Yeah,
this part about immutable infrastructure seems particularly relevant.
it is.
It's not just about efficiency and agility.
Right.
It's about building security into the foundation of your infrastructure.
Absolutely. Remember how those old golden image servers were essentially snapshots in time,
Right.
quickly becoming outdated and vulnerable?
Yeah.
With Packer and immutable infrastructure,
Okay.
you're constantly creating fresh images,
Got
incorporating the latest security updates and configurations.
So instead of trying to patch and update existing servers,
Yeah.
which can be a nightmare,
For sure.
you're essentially starting with a clean slate each time.
Exactly. And because the build process is automated,
Right.
you can ensure that those security best practices are applied consistently across all your images.
Okay.
No more inconsistencies or human error slipping through the cracks.
So Packer isn't just automating the image creation process,
Right.
it's automating security as well.
It is.
That's a powerful combination.
Yeah.
Are there any other ways Packer helps to enhance security?
Well, remember those provisioners we talked about?
Yeah.
They're not just for configuring software and settings.
Right.
They can also be used to integrate security scanning tools right into your Packer builds.
So I could have a provisioner that runs a vulnerability scan on the image as it's being built,
Yes.
catching any potential issues before they even make it to production.
Exactly. And you can take this a step further by integrating Packer into your continuous integration and continuous delivery pipelines.
Okay.
Every time a developer commits code,
Right.
your CI/CD pipeline can trigger a Packer build,
Okay.
creating a fresh image with the latest code and the latest security updates.
That's incredible. It's like having this automated security watchdog,
Right.
constantly monitoring your infrastructure,
Yeah.
ensuring that only the most secure and up-to-date images are being deployed.
Exactly.
No more waiting for manual security checks or hoping that everything is configured correctly.
It's about shifting left on security,
Okay.
catching issues early in the development lifecycle,
Mm,
rather than scrambling to fix them in production when it's often too late.
right.
Packer empowers you to build security into every stage of your infrastructure.
Wow, we've really gone deep on Packer today. From its ability to tame image sprawl to its role in enabling immutable infrastructure and enhancing security.
Yeah.
It's clear that Packer is a powerful and versatile tool that can truly revolutionize how we manage our infrastructure.
It truly is, and it's a testament to the power of automation and the growing importance of treating infrastructure as code.
As we wrap up our deep dive,
Right.
I want to leave our listeners with one final thought, something to ponder as they explore the world of Packer.
Right.
We've talked about building consistent base images,
Right.
but what about customizing those images for specific applications or environments?
That's a great point. While consistent base images are the foundation,
Okay.
the real magic happens when you start tailoring those images to meet the specific needs of your applications.
So I could take a base Ubuntu image built by Packer
Yes.
and then layer on additional software and configurations
Yeah.
specific to my web application, my
Yeah.
database server,
Yeah.
or even my machine learning environment.
Exactly. Packer gives you the building blocks and the tools to create specialized images that are optimized for different use cases.
Okay.
You can use variables, provisioners, and post-processors to create a wide range of customized images
Yes.
from a common set of base templates.
That's incredibly powerful. It's like having this adaptable system
Yeah.
where I can mix and match different components to create the perfect image for any situation.
That's the beauty of Packer.
Mhm.
It's flexible, powerful, and
Definitely.
integrates seamlessly with other tools and workflows.
Right.
It's a tool that can truly transform how you approach infrastructure management.
This has been an incredible deep dive. We've learned so much about Packer.
We have.
And I'm sure our listener is ready to start exploring its potential in their own work.
I completely agree. And if this deep dive has sparked their curiosity,
Okay.
I encourage them to check out the show notes for links to all the resources we've discussed.
Okay.
There's a wealth of information available online,
Right.
and the Packer community is incredibly active and supportive.
That's a perfect note to end on. So, until next time, keep diving deep and exploring the amazing world of technology.